Welcome, everybody, to the first webinar of today, an introduction to the Salesforce Mobile SDK. We are going to be talking specifically about building iOS applications today. So a good morning to you or a good afternoon, depending on where you are today, what particular time zone. I will actually be hailing from the Central Time Zone in my sunny city of Chicago, and I will be joined by Kevin over in San Francisco. Now, it would not be a Salesforce presentation if we didn't go through the safe harbor slide. If you haven't seen this before, basically this just says that if you're going to make any purchasing decisions, please make them based on current features and not any future-looking statements that myself or Kevin might make. And speaking of, allow us to introduce ourselves. My name is Josh Burke. I'm a developer evangelist here at Salesforce.com, and you can catch me on the Twitter at Josh Burke, and please feel free to give me a shout out either during or after the webinar if you've got any questions. And I am joined today by Mr. Kevin Hawkins, one of our mobile SDK team leads. Kevin, why don't you introduce yourself to the crowd?
Thanks, Josh. Good morning, everyone. My name is Kevin Hawkins, and I'm a software developer here at Salesforce on the mobile SDK. We're building frameworks to help our customers and ISVs more easily get their mobile apps up and running on the Salesforce platform.
Now, if you would like to follow us in your favorite social media channel of choice, we do have a lot of flavors for you. Our official Twitter account is @force.com, and if you would like to give us a shout out during the webinar, you can use the hashtag #ForceWebinar, and we will be monitoring that. We also have a Facebook page, a Google Plus Circle, a YouTube channel, as well as a LinkedIn group. Now, if you have any questions during the webinar, we do have some panelists who are on hand in order to try to answer your questions in real time. Go to the GoToWebinar questions pane and just go ahead and enter your questions in there. We will try to get your questions as you ask them, but those questions are also going to be submitted back to Kevin and myself for a Q&A session towards the end of the webinar. So at the end of the webinar, we'll take about 10 to 15 minutes to go through your questions. And also, we typically publish an FAQ once the webinar goes live on developer.force.com. So if your first question is, will this webinar be recorded? The answer is yes, it will be recorded. We usually put it up on developer.force.com about a week after the webinar is broadcasted. We've got an agenda here to basically walk you through the basics of creating your first iOS application for Salesforce. I am going to walk you through some of the prerequisites, some of the things that you should know before you even start coding. You know, what do you need in order to start building your iOS application? What should you be doing within your Salesforce org to get ready for it? And then Kevin is going to take the sample application that I'll be finishing with, and he's going to walk you through the basic structure of it, as well as being able to extend that sample application for a little bit more fuller functionality. Then finally, we're going to wrap up with some resources that you can go home with, as well as the aforementioned Q&A. Now, very quickly, Salesforce has the answer for every mobile need. We've got our core applications, which are basically downloadable apps that you can just download and go, and that includes Salesforce Mobile, Salesforce Touch, and Chatter. But today, we are talking mostly about the Salesforce platform, which allows you to create custom mobile applications designed for yourself, your employees, your customers, your partners. And if you would like to sell those mobile applications, you can do so on the App Exchange, our enterprise exchange up in the cloud. Now, if there's a couple of URLs that I really want you to remember, well, I always want people to remember developer.force.com, our main portal for Salesforce platform development. But for today, I also want to call out developer.force.com/mobile, which is our portal page for the Salesforce platform mobile services. And this is going to include things like documentation, wiki articles, information on new releases, links to our mobile packs, which are JavaScript libraries for getting up and running for various JavaScript frameworks, as well as links to and information about the latest version of the mobile SDK. And speaking of, while my guest today really is Kevin, kind of our star of the show today is the Salesforce Mobile SDK 2.0 itself. And to give you kind of an overview of that once again, remember the Mobile SDK is really designed for developers of all levels and developers who want to bring their own languages in order to build their applications. So in previous webinars, we have talked about things like hybrid application. Today we are focusing on native application. And what you're going to see today is we're going to really highlight on some of the core features of the mobile SDK. And so you're going to see how easy it is in order to use OAuth in order to authenticate and identify your users, as well as the API wrappers, which make it very easy to access and use the REST API that comes with the Salesforce platform. So let's go ahead and start talking about what you would need in order to start creating your own iOS application for the platform. The first thing you're probably going to want to do is get Node.js and NPM installed. If you're not familiar with Node.js, it is basically server-side JavaScript, and people are using it for things like creating web applications, but you can also use it for handy cross-platform utility applications, which is exactly what we have done with the latest version of the mobile SDK. And NPM is a Node Package Manager, and basically this just makes it very easy to install and update applications using Node.js. And so the first thing you're going to want to do in order to get running with an iOS application on the Salesforce platform is this npm install force iOS. So in fact, if I go to my command line and if I hit npm install force iOS, you'll see npm will run out to the registry. It's going to find force iOS. It's going to bring down the latest version and go ahead and install that for me on my laptop. Now I'm going to cancel out of this because it will take a little while and I already have it installed. But that command will allow me to install it as well as update the iOS, force iOS, if later versions come out. So the other thing that we want to do before we really get up and running is defining our connected application. And the reason for that is because we're going to be using OAuth for our authentication protocol. If you're not familiar with OAuth, you actually probably are, because it is standard for authentication when it comes to situations of third parties accessing first-party user information. Microsoft uses it, Google uses it, Facebook uses it, Twitter uses it, and obviously we use it. And the concept is that this third-party application, be it a web application or a mobile application, will actually use the first party in order to authenticate the user. So when you do this through, say, Facebook, and a Farmville application wants you to confirm a few permissions, and you confirm that that third-party application has never seen your username and password. You're always going to go through your first party for the actual username and password, in this case, login.salesforce.com. But in order to get that up and running, Salesforce needs to know what application is requesting these user permissions. And in order to do that on the Salesforce platform, you define what's called a connected app. And so if I go over to my Developer Edition org, that's an FAQ. If I go over to my Developer Edition org here, we see I am on my setup screen. And if I go over to the left menu here, I can just do a quick filter down to apps. I'll go down to apps here, and then scroll down. You can see I've already defined several connected applications. Let me go into test application here. So once I've defined a connected application, we see some basic information like the name and the actual version. But one of the most important pieces of information is right here. This is our consumer key. Now, just because of kind of the way OAuth is defined, there aren't industry standard terms for a lot of these keys, so you're actually going to see these keys referred to in different ways in different applications. Here we're seeing it as a consumer key. You might also see it referred to as a public key or an application ID or a connected app ID. Basically, if we're trying to define your app, it is going to be here on the consumer key. And then in some instances, you're also going to want to have the consumer secret as well. And you can click to reveal that. Now, the other really important piece of information is this callback URL. Now, on a normal web application where I have a web server sitting out there on the internet, and that is going to take the resulting information from the OAuth flow and do things like parse out the authentication credentials and the token that I can use for a session. This would just be an HTTPS endpoint. But we're actually going to be talking to a native application, so there is no endpoint out there on the internet. And so in order to use that, we use what I like to call a protocol, which is basically a protocol that just does not exist. And our connected app definition will say, oh, you're using your own version of a protocol. I'm going to assume that you are doing a native application, and that your native application is actually going to parse this URL in the code itself to do things like grab the user credentials and the session token. And then finally over here, we define the OAuth scope. And this is basically going to be the same as the permissions that we are going to be requesting when we're going through the OAuth flow. So in this case, the refresh token is going to allow us to log back in as the user without them having to resubmit their username and password to the first party, and then also being able to access things like the REST API. So we have NPM, we have Force iOS installed. I have my connected application defined. So the next thing that I'm going to want to do is actually create my sample application so that I can kind of get up and running very easily. And in order to do that, I can just do Force iOS create. And if you were a participant in the hybrid webinar, you might be familiar with these hybrid remote, hybrid local, but in this case what I want is I want a native sample application. So we're going to call this test application, give it some company identifiers, Salesforce, I'll go to the default directory, and then here we see it's requesting my connected app ID. And so once again, that is going to be my consumer key. So I'm going to grab my consumer key, go back to my command line and enter that in. And then the next thing it wants to know is it wants to know my connected app callback. So we'll go ahead and grab that, copy that in, paste that in, and then it's going to run through and it's going to create a new directory for me. And if we go into that directory, we can see I have two different things. One is a directory of all of the actual application code, the project, and then we have the product itself. So if I just do open test application, we will launch into Xcode. And the great thing about the sample application is by giving it that basic information, I now have a sample application that is going to go ahead and do that baseline stuff for me. So like accessing the authentication flow as well as the REST API. So if I just, without doing any additional code, if I just go ahead and run this against the iPhone simulator, there he is. We can see that it goes ahead and launches. It starts the OAuth flow for authentication, and I am going to go ahead and log in here. I'll do the equivalent of typing underneath the table here. And we can see that we have this prompt, which is very familiar to us if we've gone through any kind of OAuth flow. It identifies me as the user, it identifies the application that is requesting permissions, and then it's telling me what permissions it is requesting. So I will go ahead and hit allow on that. And then we have a REST API call out. It's currently just grabbing the users off of my org and then putting that into a list view. So a very basic sample application. Once again, it gets me up and running with those core pieces of functionality, being able to authenticate the user, identify the user, and then be able to securely access the REST API as that user. Now, to take us to the next level with the sample application, I am going to hand things over to Mr. Kevin Hawkins, who is going to walk us through the code of this application a little bit, as well as taking us to the next step of what the sample application could do.
Thank you, Josh. And go ahead and show my screen here. So what we're going to do here is we're going to basically pick up where Josh left off. I want to walk you through the basic template application that's generated when you generate a native app with Force iOS. And then we're going to go ahead and we're going to extend that app to try to do a little bit more, show a little bit more about what we can do to make changes to data that we pull down with seeing the details, and finally get those changes back up to Salesforce. Now, the first thing I want to say is that we got a fair amount of material here, and we'll probably be going through it fairly quickly. So if anything sort of goes past you and you're sort of lost or feeling like you don't know what's going on, do not panic. We have a very good comprehensive tutorial that covers this material, as well as a finished sample app at the end, and we'll have links to that so that you can go through at your own pace and see a little bit more of the details behind how this is going to work. So like I said, I want to pick up where Josh left off and sort of walk through what the app currently does just out of the box. So I'm going to do another run through here. I've named my app Warehouse App because we're going to actually end up using the warehouse schema to make some inventory changes to our app from what we have basically here. But right now, this is just the sample template app. And if I run through, you'll see it's building, and I go to my simulator, and you'll see that it's going to ask me to log in here. And I've defined my own connected app, which I've called Warehouse App, but it's basically asking for the same permissions and whatnot. You can see my username up here. I'm going to go ahead and allow that. And as you just saw, essentially drops you into a screen that has some of the users of the org. So let's go through and actually see what's going on behind the scenes. I'm going to go into our app delegate.m, which is the entry point for any iOS app is where you're going to land. And let's just walk through and see some of the details of what's going on here. If you look here at the top, you'll see my connected app is defined here. You'll recognize that in my redirect URI. Those are essential for the app identifying itself to the Salesforce service. And let's scroll down here, and I want to show you. We're not going to walk through too much of this file, but I want to focus on the details of the application itself. But I want to briefly show you just how simple it is to get up and running with authentication to get into your app. So the first thing you'll see is in our initialization here, we have what we've defined here as the initial login success block and failure block. And these are going to get called once the authentication completes. It needs to know, hey, what am I going to do after my authentication completes? The failure block, we just say standard, hey, if authentication failed, let's go through the logout procedure and kind of start over. You'll see in the success block here, we call this method called setup root view controller. And that's essentially what allows us to go into the app. We'll show you that here in a minute. It defines what's going to happen after authentication. And we'll scroll down here to application did finish launching with options, which is basically gets called the first time the app is launched. And you'll see here all that we're doing for authentication is calling this authentication manager, shared manager, login with completion. And you'll see we've said in our initial login success and failure blocks. And that's all you really need to do to get authentication going. You can put that really anywhere in your app that you need to start on authentication. For us, we just decided that's, at the beginning of the app's lifecycle is the best time to do that. So we do that. And then, so let's go through and see what happens after that. And so we go down here to our setup root view controller. And this is where we start defining how our app is going to behave after the fact. So you'll see here, what we do is we create this root view controller. You'll see we initialize that. And that's just a class over here. I'll open that up over here in another pane in the header file. We'll get back to that in a minute, but that's our class. We've created that, and that's sort of the basis of what our app is going to do. So we initialize that, and you'll see here then we create a navigation controller. Now, UI navigation controller is an iOS Cocoa-based class that is a container class for different view controllers, and what it does is it gives you a lot of navigation between views for free. It allows you to wire up different views so you can have one view and go into another view and go back and sort of navigate up and down the stack of views in a very easy to manage way. In the sample app, we don't navigate anywhere, but we've set it up like that. Maybe just for these purposes. No, it's actually just a good paradigm. It's a fairly standard way to control your app in iOS. So we go ahead and we say we're going to initialize that with our root view controller there, you'll see. And then finally we say with our window, the root view controller is our navigation controller. And window.rootViewController is essentially, that's the top of your app. That's what's going to be the basis of what's going to be displayed on your screen. So we're saying, okay, now this is what I want to show. So with that, let's go ahead and go into root view controller because that's essentially going to be shown in the navigation controller container here. So if we go in here, the first thing you'll notice is that root view controller inherits from UI table view controller. Now this is another Objective-C Cocoa class that Apple provides for you. that allows you to have a lot of things for free on being able to display lists of data. So we're inherently bringing back lists of data in this particular application, and the UI Table View Controller gives you the means to style that data, to react to when people click on the data. It gives you a lot of that stuff wired up for free. It makes it a lot easier to sort of manage data in that sort of list view. So we're doing that. You'll see here we are implementing the SF REST delegate, and I will get back to that in a moment to show you why that is and how that works. So let's go into the implementation of this class. So we'll go into root view controller.m, and let's just go down the list and kind of see what we've got here. The first class of interest is the view did load. Now this is a class that's on any UI view controller. It starts the view lifecycle of the application, and this method will be called only one time. When the view is first loaded, the view did load, it will launch. It will never launch again in the view's lifetime. But when your view initializes, the things that you need to do when you know that the UI can be ready, this is the method you would call. And this is where we start initializing our application here. You'll see self.title is we set the mobile SDK app, and you'll see that's this title up here. And self.title is actually a property of the navigation controller, which allows you to set, this bar up here is actually the navigation bar. We don't have any navigation on there at the moment, but that's where that'll live. And this gives you a means to title that, sort of say what view that you're on. So we set that to sample app. The next thing that you'll see is that we generate a REST request. Then this is going to contact Salesforce. This is part of the mobile SDK here. And you'll see SF REST API gives you this request for query. It's just one of many factory methods that allows you to create different requests for how you're going to interact with the Salesforce REST APIs. In this particular case, request for query just allows us to create a REST request that we can put in SOQL and make a basic query to get data back from the service. And you'll see here we have a very simple query. We're selecting the name from the user table, and we're limiting that to 10 users. So that's what's pulling back our user data, and we're really only making use of the name, so that's all we pull back. And you'll see here that once we form that request, we tell SF REST API, please send that request. And then the point of interest here is the delegate, and the delegate we say to self, we set that to self, which is Objective-C's way of talking about the class that you're in now. Now, what the delegate does for you is the REST request is going to be inherently asynchronous. That means you're going to fire it off, and then there's some time is going to pass, and then you're going to get data back. But once it's fired off, you will no longer be connected to that request directly. So what the delegate allows you to do is to say, hey, once you have a response for me, send it back to me, and I'll handle that when it comes in. And if you'll remember from over here, that's what the SF REST delegate protocol is allowing us to do here. When we say delegate is self, the SF REST delegate protocol is what we basically allows us to form up the methods that will respond to a particular request. So. And then here we go. You see that right down here is the next set of methods are the delegate methods that we have implemented. The last three methods are not particularly interesting at this point. You would probably do different things to flesh out this behavior. We have did fail load with error, which is in case there's an error that comes back. And we're just going to log the error in the console down here, which I'll expand just in case we want to see that and bring that up a little bit. That's where your console messages are going to go with nslog. If the user canceled the load, this method will be called requested cancel load. And finally, if the request timed out, you'll get this timeout response, and you'll be able to handle that accordingly. We haven't really implemented that. And what we have implemented of interest is the did load response, and this is sort of the down the middle case. What happens when we get data back? And you'll see here that we get back a JSON response from the REST APIs. And this is where we're going to respond to our data and actually display it. So the first thing that we do is we pull the records out of the JSON response. You'll see object for key records. That's pretty standard on a lot of Salesforce objects. The records are going to be the actual data rows that come back from your REST request. And so we're pulling those out into this NS array of records. You see we log the number of records that came back, and that'll show up on the console. And now we set self.dataRows to records. Now data rows is an element on the UI table view controller, and that's essentially what wires up your data with what you're going to show in your view. So that's how the table view controller knows what you want to use for your data. So we're saying, you know, that's just going to be our array of records. We're going to go ahead and set that, and that's what we will work with in each row of the table view. And finally, we tell the table view, hey, I've got some new data, reload it so that the user sees the new data. Okay, so as I mentioned down here, the table view gives you a lot of functionality for free that you need to wire up to define how your table view is going to look. So we have a number of these methods here. The first couple are not super interesting. Number of sections in table views, just the number of sections. You can have multiple sections. We only have one, just one list of data that comes back. Number of rows in selection, we just say that's the number of rows in our data rows. So that the application knows. And then finally, what we have implemented here is cell for row at index path. And what that allows us to do is essentially style each row of the table to show you, how you want to display the data, what you want to present to the user. So let's walk through and see what's going on here. The first thing that we do is you'll see this UI table view cell is calls DQ reusable cell with identifier. This is just a fancy way of recycling cells in memory. So if you think about scrolling a table view, once those cells are off the screen, the application doesn't actually need to keep them in memory. So what you can do here is essentially recycle those cells, and when new cells are coming onto the screen, you can say, hey, just give me the cell that you had, and I'll populate that. And so that's what we're doing here. And then you'll see if we don't get back any data for that, if there aren't any queued reusable cells, then we go ahead and create one. And you'll see this init with style. We give it a default table style. And finally, we give it our reuse identifier, which kind of keeps the whole cycle going so that those can be used in that sort of reuse block. You'll see down here, cell.imageview.image. We're just pulling the icon of the app, and we set that to the image view .image, and that's what you'll see over here on the left-hand side. That's just the icon of the app. If we go through here and you see that's basically the same icon, and that's one of those things you just kind of get for free. And down here you'll see this is where we actually show the data. Now we have access to the row up here. You'll see in our signature of the method, you'll see we have the cells for row at index path. And index path contains where the index lives, among other things. So here we're saying, okay, well, the object at index path.row, you'll remember our array of data rows here, which we have. That's basically just going to be one of the names that we've retrieved. So we get back, that would be a name value pair dictionary, but we only have really one name and value. But nevertheless, it's in an NS dictionary, and so we pull that out, and then we say, okay, well, the text I'm going to show in my cell is going to be the object that's stored for name, and that's where you see here our username and each of our users that comes down the list there. Finally, the last thing you'll see here is, and you'll see the comment here, is adds the arrow to the right-hand side, and that's cell.accessory-type. That's what gives us our little chevron arrow over here. So that's pretty much it for the way the sample app currently works, and which is a good start. But there's any number of things that we can do to sort of make this more useful. You'll see we can click here, but it doesn't really give us anything. It doesn't do anything for us. So what we want to do here is we're going to extend this app to actually do something useful, and to do that, we're going to use the warehouse schema, which is part of many of our samples, and allows us to essentially manage inventory in a warehouse. And what we're going to want to do is be able to see details of each of those items that we've clicked on, and then interact with those details and be able to change data and make updates to it and so on. So we're going to do that by we're going to take this template app, and we're going to change this app to start being the app that we want it to be. So without further ado, let's go through, start looking at that refactoring process. So let's start with our root view controller here, okay? The first thing is that, root view controller, that's a good name for a sample app, but it doesn't really define what our app is going to do, and we want to have sort of meaningful names for our app. So I'm going to change the name of this class to be something more meaningful. I want to change it to warehouse view controller. And the way I'm going to do that is I'm going to go to this implementation name, and I'm going to right click on that. I'm going to go to refactor, and I'm going to go to rename here. And that allows me to rename all the references, not just this name here, but all the references to this class within the project. So it's a really easy way to make sort of bulk changes across your project. So I'm going to change this name to Warehouse View Controller. And you'll see the checkbox here for rename related files. That'll only really come up if you're renaming a class. You can rename methods or variable names as well, but if you're renaming a class, it'll say, hey, do you want to rename the file names of that class too, so that we turn root view controller.h and .m into warehouse view controller. We're going to go ahead and do that so that we have that meaningful name everywhere. So I click preview, sort of shows me what's going to happen, and you'll see you have app delegate, warehouse view controller. This is all the references that are going to be in the class, and down the right-hand pane, you'll see what exists today. And on the left-hand pane, you'll see the sort of preview of what it's going to be once you make the changes. And it's going to be, an import there, and you'll see, we've set the class down here, and basically all the references in the project. And that's going to be good for me. And so I'm going to say, yeah, that change is good. I'm going to save that. You'll see this dialog come up and saying, do you want to take snapshots? That essentially allows you to roll back on this change if it causes something catastrophic to happen. For the demo, I'm just going to disable that. So I go through, and voila, everything should be called Warehouse View Controller now. And you can see over here in the project pane, we've got Warehouse View Controller .h and .m now. Okay, so that gives us a better name. Now let's go through and make some more cosmetic changes to how our app is actually going to display. The first thing I want to see is in View Did Load. I have this title, Mobile SDK Sample App. That doesn't really reflect what our app is anymore. Let's call this Warehouse App. So change that name so when that view comes up, it will be called Warehouse App, and everyone will know where they are. The next thing that I want to change is the request. We don't really want to pull users anymore. We're going to go ahead and pull data from the merchandise table so that we can interact with that data instead. Now, we're going to keep the name because that's useful to us. We'll use that still to display. I'm going to get the ID, which is the object ID. We'll use that to interact with the data with the REST APIs once we want to change it. And then finally, I'm going to get the quantity of items that we have. So that's quantity underscore C. And finally, I'm going to get the price as well. Underscore C. And we're not going from the user table anymore. We're going from the merchandise table. Merchandise. Yep. Minus my typos. Merchandise underscore C. And we'll go ahead and limit that to 10 as well. And so this is a good point to check and see how things have gone, because you should see now, without any other changes, the new changes that you've implemented in your app when you run it. So let's go ahead and run that guy and see what we come up with here. I'm going to run this again. I've already logged in, so it allows me to log in again. And there you'll see now we have Warehouse App up here at the top, and you'll see that we have our line items, laptop, desktop, different items in the warehouse, which is great. But what's not great is that you still don't really get anything when you click on these items, and we want to be able to actually interact with the details of these items. So that's the next thing that we're going to implement. So what we're going to do for that is we are going to create a detail view controller that will show the details of each of those items when you click in on them. Now, I've already implemented the detail view controller for the purposes of time in this exercise. In the tutorial, you'll actually be able to go through step by step and create this class from whole cloth. But for now, let's just walk through and see what some of this is going to look like here in the detail view controller. So I'm going to pull up the user interface file for this, and you'll see it's basically a very simple interface. You're going to see the name of the object, and you'll get the price and a text box to interact with the price. Same for the quantity. And finally, a big update button. Once you've made the changes you want and we've implemented update details, you'll be able to interact there. So we'll get back to that in a minute, but let's go ahead and wire that up first of all and see how that guy works. And we're going to do that by going back to our Warehouse View Controller. And you'll remember from before, we have these table view methods that allow us to interact with the table view. Well, one of the things that we want to be able to do here is another table view method, which allows us to actually interact with the cells when the user touches on them. And that method, I'm going to start typing here, is called table view did select row at index path. And you'll see that it starts to highlight there. There are a number of choices that I can pick. It happens to be on the one that I want here, did select row at index path. That allows you to make changes to the row or to take action when the user touches on the row. So I'm going to hit enter to go ahead and accept that as my method signature. And we're going to make this so that when the user clicks on that, we can actually load the table view. So first thing that we want to do is this, just for naming conventions, it's a little confusing. You'll remember that we have a table view property that we defined, or I'm sorry, that's defined on the table view, and that name can actually sort of clash with this name if you're not careful. I like to just change the name here so that there's no discrepancy about which variable name we're using there. So I'm going to change that there. And now the first thing that I actually want to do in the implementation here is you'll notice when you go and you click on the, well, I don't have it open now, but when you clicked on the rows, you'll notice that it stays highlighted. That's when the selection happens. The highlighting actually happens on the item. And just for clarity, we want to remove that highlighting. We want to deselect the row. It's just so that the user doesn't get confused. So I can go ahead to my item table view, and we're going to say we're going to deselect that row at index path. And you see we have our index path up there, so I'm just going to specify that. And we're not going to animate it because we're not actually going to see it. We're going to be pushing another view onto the stack when we do that. So it doesn't need to be animated. We'll just allow that to change. The next thing we want to do is we actually need to get access to the data so that we know what detail view that we're going to go into. So that's similar to what we had up here. You'll see that we took the data row object at index path, and we're going to do the same thing here. So I'm going to say, I'm going to have an NS dictionary and call that object, and we're going to say that that's equal to our self.dataRows object at index path.row. Okay, that gives us access to the data in this, and we have actually more data members in here in our dictionaries. So, and we're going to make use of those when we load up the detail view controller. So let's go ahead and load that detail view controller. Now, the first thing that we need to do is actually tell this class about the detail view controller so that it knows how to interact with it. So I'm going to add that detail view controller.h, and that's going to allow us to instantiate a detail view controller. So we can now do that. We say detail view controller. I'll call it DVC. And I'm going to go ahead and allocate that. Oops. Let's go back there. Okay, alloc. And you'll see we start typing in it, and we have a method that we've defined, and we'll get to this when we go through the detail view controller, that allows us to initialize this object with all of the data that we have received from the index row that will populate the detail view. So I'm going to go ahead and sort of auto-complete that. It allows me to fill in the names for each of these items, and that's just going to be the values in my dictionary that I just set up. So I'm going to say object for key name is the name of that guy. Our SObject ID is going to be object for key ID. And you hopefully remember these from our query above. Quantity will start to look familiar. Object for key quantity underscore C. And finally, our price, which is going to be object for key price underscore C. Okay, that allows us to create our detail view controller, and it looks like I'm still missing something it doesn't like. So let's see what the error says here. We're expecting another bracket, so let's see where we missed one. Object for key. Oh, I missed my closing bracket. There we go. Xcode is happy. Okay, so now that we have that, now we need to push that detail view controller onto the stack. We need to tell the application, how am I going to view this detail view controller? And we do that through our navigation controller. So we go self navigation controller, and I'm going to push this view controller onto the stack. And so that's DVC. And we are going to animate that because the user is actually going to see that when we go through. So we've got that. Now we should be able to run this guy and actually see us go into the detail view controller. So let's give it a shot. We go in here, we load up again, and let's go into laptop, and you'll see, there we go. We actually get the details of our laptop. And as I mentioned before, with the navigation controller, you actually have the means to navigate between the app, the detail view, and to go back into the master view, and you get that for free, and that's pretty nice. So we can navigate between our different items here. So that's great. We can do that, but what we can't do yet, or what we can do in the finished product, which you wouldn't be able to do in the sample app in the tutorial, is to actually make updates that would stick. And while we can do that now, I actually want to walk through some of that and show you what's going on there. So let's go back to our detail view controller here. And let's take a look. I'm going to go ahead and open the assistant editor to show you how some of this stuff is wired up. So let's close this here. We get a little more space. And I'm just going to highlight over these connections here to show you what's going on. So you'll see that we have an outlet to our name label, to our price field, and to our quantity field. And that's going to allow us to edit those values within the code itself. And then finally, down here, you'll see we have an action. And what that's going to do is that when we click the update button, we're going to be able to call this method update touch up inside and to run the updates that we want to do. So that sort of shows how this is wired up. We've got some properties here that are going to store the data, and you'll see our signature for our init with name that we just accessed in the previous in the master view controller to create this view. So let's look at some of the details of what we've got in our detail view controller code. Okay, so you'll see init with name here. Let's look at the implementation here. We actually set those properties that were defined to the data that's coming in. So record name, Salesforce ID, record quantity. We set background properties for that will contain all of that data, and we can send that around and interact with it in the web view. So you see we get that data here. Now in this particular example, we're not doing anything with the view did load, but we are implementing the view will appear. And view will appear is similar to view did load, except that it will get fired off every time the view actually comes onto the screen, whereas view did load only gets called once. This will happen every time this view shows up, and we want to be able to update that data every time the view is refreshed, essentially. So that's why we're implementing this guy. And you'll see, remember our properties we defined over here, our name label, price field. So this is where we're going to set that data. So you'll see that we set the name label to the name property that we set, the quantity value that we got in, and the price value that we got in. And that's what allows those fields to be filled every time that the app starts. So let's go down to our update touch up inside. It's going to happen when you click the update button. As you saw over here, you see that outlet goes to the update touch. So when you update, this is what's going to allow you to update that data. So you'll see we basically what we do here is we call a helper method that update with object type, object ID, quantity, and price, so that we can just pass in that data behind the scenes and kind of do what we need to do. So we're updating the merchandise table. You'll see the ID. We never display that, but we need that data to interact with the REST API. And finally, we're going to take the values that the user has keyed in, if any, and pass those back up as well. So that's what we pass in here. If we look at the implementation of this method, this is basically going to form up our REST request and send it back to Salesforce so that we can update that data. So you'll see the first thing that we do is we set a dictionary of updated fields here. That's going to be the data that we're updating, and we set that with the quantity and price that we passed in for these price underscore C, quantity underscore C. So that's our data that we're going to update. And now you'll see here in the SF REST API, this is another factory method that you get for free on SF REST API. This is one that's going to create a REST request for updating data on Salesforce. So request for update with object type. You'll see the object type that we passed in, the object ID to identify the object, and finally the fields that we're going to update. Now you'll see here that similar to the master view, we're doing a send. We're going to send that request. And as well as in the master view, we're setting the delegate to self so that we are going to handle the response here. Now when we get the response on this one, again, we didn't really do much with these three methods. It'll log errors if they come up or the different views, but we focused on it down the middle. What happens when we load the response? So what we're doing here is we're going to wait for the response to come back from the service before we take further action from this view. So you'll see we log that a record was updated. And then finally, we say self-navigation controller, pop view controller animated. And what that says is once we've gotten a response back that you've updated that data, we're going to take the detail view off the stack and we're going to go back to our master view. This is how we can do that programmatically. So let's take a look at that in action and see how it works. I'm going to run the app again. I'm going to go into laptop, and My price is 500, and I'm going to go ahead and change that to 525. Laptops are selling well, since we've sold, let's say, 500 of them, so we'll drop the quantity down to 1,000. And when I click the update button, you might see a brief pause, and then it goes back. You'll see, let's go over to our console here. You'll see one record updated, so you know that our request did load response, got called, and then it popped back out, which is pretty good, and there's just going to be one small problem. Let's go back into laptop and look at the details. And you notice, oh no, none of the changes have actually appeared. I still have the same values, and that's not going to make my users happy with, well, maybe it will since I increased the price, but it's not going to make me happy because my app's not performing properly. And the reason for that, if you remember what I said with view did load versus view will appear, let's go back over to the warehouse view controller here and take a look. Remember that I said that view did load only loads the very first time that this view is loaded. And that, in the warehouse view controller, is where we get our data. So the first time that that view loads, that's the only time we're going to get that data, and we're not going to see any updates that come in. So what we really want to do is implement view will appear. So basically the same as a detail view controller, we want to be able to update that view every time it comes back onto the screen so we don't have any data disparities. So let's just go ahead and implement that. You can implement these on any view controller that you have. And as with others, it'll show up as I start to type in. And I'm going to go ahead and say, yes, that's what I want. Most every class you're going to call a super method if you are implementing from a parent class. So we're going to go ahead and do that. And finally, we're just going to move this query down here since it'll load the first time and every other time after that. We don't need to do it here. We'll just do it every time the view appears. So I'm going to copy and paste that guy down there. And so let's do a final run through and see what we get. So I'm going to run this guy. You'll see our query ran OK on here. And this isn't really a fair test because with the laptop, we have loaded the view the first time. So that would have worked that way anyway to see the updates, the 525 and down to 1,000. But let's make another change here. Let's say the desktop. And we'll go ahead and make a change here. And we'll do a price drop to $11.50 because we have 150 in stock. We'll run the update there. You see we go back there. And voila, the changes have shown up. So that's pretty much it. That's a good walkthrough of how to create a master view, detail view for your app to be able to interact with data from the Salesforce REST APIs, be able to edit it locally, and finally push changes up to the cloud. So with that, I'm going to turn it back over to Josh, who will take us out.
All right. Let me see if I can grab. Excuse us a second while we run through all of our. Here we go. Grabbing control back from Kevin and flipping back over to PowerPoint. Here we go. All right. So yes, let's quickly just do a quick recap, and then we can get into your questions. So we did a quick getting started with the mobile SDK and showing you some of the ways to get into that sample application. The first part, that's setting up your connected application, that is installing Node and NPM, installing the SDK itself, and then using Force iOS Create to go ahead and create that sample application. And then Kevin walked us through an overview of what that sample application actually contains, and then how we can use some of the core objects like SF REST API and SF REST request in order to communicate back to the REST API. So, and if you're looking at this slide right now and you're frantically going to write down a bunch of links, don't worry, the links will be showing up both in the GoToWebinar control panel, I believe, and when we're going through our Q&A, I will flip back to this slide so that you guys can easily see it. But once again, remember the developer.force.com/mobile for our mobile services portal. The mobile SDK itself you can install with npm install Force iOS. And you can also go to our GitHub account at force.com, which has the open source for both the iOS version of the SDK, the Android version of the SDK, virtually everything that we're seeing with the mobile SDK is open source up on GitHub. So if you want to actually poke around at the code that is making this stuff fly, you can see what we're doing in the background. And then the two links that if you're wondering how you could go through and actually get this sample application running the same way that Kevin was showing is we have a bit.ly link here, iOS SDK Workbook, and that is going to allow you to actually go through the steps that Kevin was talking about. So as Kevin was going through this, you could walk through those same steps and create the same end sample application with a working root view controller and a working detail view controller. And then we also have an iOS warehouse example. This is the full warehouse example, so if you're the kind of person who likes to read the last chapter of a story first, you can just go ahead and jump to the working example that Kevin was showing towards the end of his demonstration. So your next steps, if you wanted to go ahead and get this up and running yourself, if you don't already have one, grab yourself a Developer Edition account, developer.force.com/join. Once again, Developer Edition account is free. We are not going to send our marketing people after you just for signing up with it, and it's also not a trial org. It does not have any set expiration date. Go ahead and download the workbook and install Force iOS, and then you can walk through the same steps and create this working application and get that same kind of baseline functionality that Kevin was showing. Now I want to call out a few upcoming events that we have. We've got the Rapid Mobile Application Development using the Apparate.io mobile pack. This is a bit of a mouthful, but is going to give you lots of information about using Apparate.io. We also have an upcoming mobile code talk, as well as some coming soon webinars on the metadata API, some more code talk on Apex, as well as things like event notifications, and also using your sandbox to deploy up to production. Now, we do take feedback on our webinars very seriously. We take your comments and positive or negative and use them to iterate this program into its future versions. So if you can please follow this link here, bit.ly/mobile iOS survey, you will be able to fill out a very quick form which will give us some very valuable feedback. Okay, with that stated, we are going to jump into a Q&A. Once again, here are our Twitter handles if you would like to give us a shout out. Instead of this slide, however, I'm going to bounce back a couple here. I'm going to stay on this slide so that everybody who wants to be able to download those can. I'll just go ahead and pause to that. All right, so give me a second to go through some of the questions that I'm seeing here. We actually have some excellent questions. I'm actually going to start with what I think might be the easiest question that I've ever gotten on any webinar, which is what version of Xcode is Josh using? Which actually, oddly, I didn't actually know myself. I did have to go look at my Xcode. It's Xcode 4.6, so I am actually still developing against iOS 6. I am not doing any of the cool beta stuff with iOS 7 yet. So if you are developing iOS 7, you might actually be seeing a newer version of Xcode than what I'm actually using here. Another question, and Kevin, correct me if I kind of stumble over this one. I'm familiar with how this has worked in previous frameworks. I think callback URL when creating a connected app can be a dummy. So this kind of goes back to this concept of a photo call. Like, how does the photo call actually work? So we're not on an endpoint where a web server can actually bring in that URL and parse it. So my understanding, how I've seen it work in the past, is that the native code itself is in control of the browser that the user is using in order to go through this OAuth flow. So while they're out there on the web going through login.salesforce.com, they do the authentication, then our OAuth will still end with that callback URL that's provided in the connected app ID, but it doesn't actually have to go anywhere because effectively the code itself can see in that browser that the user is using that URL has appeared, and then just go from there and just pull the parsing. So it doesn't have to go to an endpoint because basically the code is in control of the browser that the user is using. Is that more or less accurate?
Yeah, that's correct. We basically, on the client side of the application, we take a look at every URL that's going to go through the browser, and when we get to the one that matches our callback URL, we say, oh, okay, that's the one that Salesforce actually sends back to us, and rather than loading that, we say, oh, okay, well, this is our time to do our thing, and we we react from there. So it's important that the callback URL follow the generic format of a URI, so that, you know, name colon slash slash, you know, other name slash other name. But beyond that, yeah, it doesn't actually get processed as a web request per se. And we actually recommend to people, some people like to use a normal URL in there, something like https login.salesforce.com/success. We actually recommend against that for the mobile apps, because there have been cases in the past where that's somehow snuck through and that there wasn't the right processing done on the client side. So as odd as it may seem, we tell people for these mobile connected apps, use something that's not really going to be processed by the browser, and you should be in good shape.
Excellent. Next question, does the REST API that this mobile SDK connect to still have the 24-hour limit for transactions? And yes, that is correct. We are accessing the standard REST API, so all governance limits are going to apply in that case. And so as you are building out your mobile application to be more complicated, it is obviously good practice to be looking how many API calls you're making, where can you shore those up, is it possible to, you know, use one API call as opposed to 3 in order to get the same kind of information. So governor limits still apply, definitely something to be aware of as you're going through your mobile application design. Next question, why do I have to install Node.js and NPM? And Kevin, they don't have to, right? Like we've used Node.js for this version because it just makes it so much easier in a few command lines to get up and running with the mobile SDK. But it is still possible to actually go out to GitHub and grab the mobile SDK and more or less install it by hand. Is that correct?
Yeah, that's correct. We use the Node.js and the NPM side of things basically for users who aren't necessarily interested in the dirty details of what's going on in the SDK itself. If you just really want to get your app up and running, you get your sample app up and be able to utilize the mobile SDK, then we recommend that because it's a lot quicker. You don't have to go through the GitHub process. You don't have to sort of build out the different templates to allow for that development like we used to do before. But you know, if you're comfortable with Git and GitHub and you want to know what's going on in the code and be able to debug through our sample apps in the projects, and you can get there either way. So we give you still all the tools to build through the SDK and to create your own projects there and run from there. So whatever way works best for you is fine. We want to give you the options that basically get you to where you need to go.
Now we actually have a series of questions about using REST API versus SOAP API and the ability to include, if people are not familiar with it, there is a library out there on GitHub called ZK-Force by Sir Simon Fell. I believe Simon was knighted last year, so I think I can call him Sir Simon Fell. The mobile SDK by default uses the REST API. ZK-Force is a SOAP API library that you can use. We do recommend REST as the best foot forward for mobile applications due to the much smaller message size and transfer that has to go through. The REST API is just using, it's much more lightweight. Kevin, are you familiar, have you seen any projects recently which have tried to kind of blend the two? Can you think of any issues of being able to include ZK-Force and including and include the application? In fact, I think, if I'm not wrong, the new version of the mobile SDK is actually easier to blend with either existing application or third-party libraries.
Yeah, that's correct. And I have seen some applications that do blend ZK-Force and our REST APIs. There are still, one example is that there are still some APIs that aren't exposed in REST that are still exposed in SOAP, or maybe that's changed in the recent past, but there is some data that was still only really available through the SOAP API. The biggest concern, I think, is sort of managing the authentication between the two. And I haven't used ZK-Force, so I'm not really sure exactly how it goes. But I think that the OAuth, you know, the authentication management between the REST API and the SOAP API is going to be somewhat different, but while not totally interchangeable, I think they're still compatible. You can still sort of make use of the authentication between the two. But otherwise, yeah, those frameworks should be able to live side by side, and you can mix and match as you need to. But yeah, as Josh said, SOAP brings a lot of overhead in the message size, and on mobile, you really want to be conscientious about the size of the data going across the wire, because that just translates directly into lag in your app.
I like this question because it's actually one of the things that I frequently forget to point out when I'm demonstrating the connected app definition. So how would an ISV using the SDK be able to create the key in the URI for a random person out there on the internet who's going to download it, because you don't know what org they're going to have? So this is one of the very few instances where you are defining something on say if you're an ISV and you're using a developer edition org to generate your application, if you define a connected app on that org, everybody else on Salesforce is going to be able to see that. So you define it once, and it is true for the Salesforce platform. So that it's an identification for your application, and is not actually necessarily bound to the org that you're defining on. And we are so instance-oriented when it comes to most things Salesforce platform. That is one thing that's easy to kind of gloss over when we're showing the connected app definition. But you define it once, and then it is true for your application. Anybody who downloads your application will be able to identify your app through the same consumer key and private key. Now, we also had a question on consumer key versus private key. As somebody was noting, as Kevin was going through the demonstration, that we're only using the consumer key here, and why don't we need the private key? And Kevin, again, you might be able to clarify this a little bit more, since you've probably done a little bit more with OAuth in general than I have. But my understanding is that the consumer key is used mostly for the common flows that we're going to use where the user is actually involved, and so the user is confirming the existence of that application. We need the consumer key and the private key in some of the OAuth flows where some of the steps between the user and the application are being removed. For instance, if you're creating a headless console application that's going to access the REST API and it's calling in through OAuth, maybe just actually submitting a username and password right off the bat, at that instance, we need both the consumer and the private key to truly identify that that is your application. But for the most part, in the mobile SDK flow that we're seeing here, we should only need a consumer key. Does that sound about right?
Yeah, that's about right. We avoid the use of the client secret because it's basically, that's sort of the public and private key pair, if you will, of the application. And with those two pieces of information, you could essentially impersonate the application in ways that we don't want to do. So we try to keep the client secret out of the applications for security reasons. Just we don't want to send that across the wire, or even more importantly, embed that in a device in an inherently insecure way. So we've set it up so that we only really need to make use of that public identifier, and then that matches with your credentials as you enter them.
Right. Okay, we're a little over the hour, but I am going to end with one last question. It is something that we certainly wish we would have had time in order to fit into a webinar, but this is very much an introductory level webinar for iOS applications. And so this will be a topic you might actually keep an eye on, developer.force.com. I will try to see if I can get a blog post out there to point to some of the most recent information. But what is the way of offline storage? And as kind of a follow-up to that, what is Cordova and PhoneGap? Those of you who may remember me from such things as the hybrid webinar, we talked to great length about Cordova. Cordova is basically a library which bridges between JavaScript and native. Since we are in pure native in this point, we do not need to concern ourselves with Cordova or PhoneGap because we can talk directly to native libraries. Now, the nice thing about how the SmartSync library works is that all of the oomph is actually being done on the native side, which means if you want to use SmartSync for your offline storage, you can actually talk directly to the SmartSync libraries right from Objective-C. And I believe the steps would be, and Kevin, once again, correct me if I'm wrong here, I think the steps would be...
Let me jump in with 1 second to just not confuse SmartSync with SmartStore. SmartSync Yeah, that's a new framework that we have out that sort of put layers on top of SmartStore to give you extended data capabilities. But that is only available on hybrid now, whereas SmartStore is available in both the hybrid and the native models. So.
Right, right. Yep. Good catch. My bad. So SmartStore is the secure offline storage that includes usage of SQL Cipher. SmartSync is basically kind of a very low-level Delta conflict engine, which is JavaScript only. So SmartStore for offline storage, you can include the SmartStore libraries in your project in a similar way that we were talking about being able to include things like ZK-Force, and you can talk to the SmartStore libraries specifically. You also have, and this is one of the nice things about working on a native project, you also have the ability to use anything else that that Xcode is going to be able to bring to the table. So you could talk to SQL Cipher on your own right, and you could also use the data storage capabilities that are included within iOS itself. So one of the nice things about native is you actually do have a few options there. Although I have in the past actually found SmartStore very easy to work with when it comes to basically just downloading some JSON data and securely storing that on the device. Okay, and with that, I believe we can go ahead and dismiss class. Once again, I want to thank everybody for joining us this morning or afternoon or early evening, wherever you are in the world. And I want to thank Kevin for bringing the knowledge and showing us all of the great samples, and also, obviously, our panelists and organizers for getting this up and running. Thank you, everybody, and once again, look for developer.force.com in about a week or so if you want to catch the recording on this and things like the finalized FAQ.